You are running a 500-node Kubernetes cluster on AWS, and your interviewer asks you a question that sounds like a trap. Why would you keep Cluster Autoscaler instead of moving to Karpenter? Most candidates freeze because they've been told Karpenter is the modern answer. But the real senior answer is knowing exactly when that's true and when it isn't. Let's talk about what interviewers are actually testing here. When a hiring panel asks this question, they are not looking for a feature comparison. You could read off a GitHub README. They want to know if you understand operational risk at scale, if you thought about blast radius, and if you can defend an architectural decision under pressure. The wrong answer is a confident, Karpenter is better, full stop. The right answer shows that you understand both tools as systems, not just as features. So let's build the mental model. Both Cluster Autoscaler, which most people call CA, and Karpenter solve the same core problem. Your cluster needs more nodes when pods can't be scheduled, and it needs fewer nodes when resources are wasted. But they solve it in completely different ways, and those differences matter a lot at 500 nodes. CA, the Cluster Autoscaler, works by watching for unschedulable pods and then scaling up predefined node groups. On AWS, those node groups are autoscaling groups, or ASGs. CA doesn't pick the instance type. You already picked it when you configured the ASG. CA just decides how many instances in that group to run. It scales down by identifying underutilized nodes and draining them, typically after a 10-minute cooldown by default, though you can tune that with the scale-down delay after add flag. Karpenter works differently. It watches for unschedulable pods too, but instead of scaling a node group, it directly calls the EC2 Fleet API and provisions exactly the instance it thinks fits best. It reads the pod's resource requests, its node selector, its topology spread constraints, and it picks an instance type on the fly. There are no ASGs involved in the core path. Karpenter uses a resource called a node pool, which is a set of constraints, not a fixed instance type. Within those constraints, Karpenter decides what to launch. Now, why does any of this matter at 500 nodes? Because at that scale, the operational properties of each system hit differently. Let's talk about predictability first. CA is boring in the best possible way. Your ASGs are defined in Terraform or CloudFormation. You know exactly which instance types are in each group. Your capacity planning team can look at an ASG and reason about it. Your cost team can forecast it. Your security team has already approved those AMIs and those launch templates. When CA scales up, it scales up exactly what you told it to scale up. There are no surprises in instance selection. Karpenter is more flexible, but flexibility has a cost. Karpenter can select from dozens of instance types based on availability and spot pricing. In a steady state, that's great. But during an incident at 2 a.m., when you're trying to understand why your node costs spiked or why a batch job landed on a C6i 32x large instead of a smaller instance, the dynamic selection can make root cause analysis harder. At 500 nodes, your monitoring and cost allocation tooling needs to account for that variance. The second dimension is ASG lock-in versus direct EC2 access. CA's dependency on ASGs is often described as a weakness, and in some contexts it is. But at 500 nodes in an enterprise environment, ASGs often carry years of configuration. Warm pools, lifecycle hooks for custom bootstrap scripts, instance refresh settings tied to your patch management process, and integration with AWS Systems Manager. If you migrate to Karpenter, you're not just swapping an autoscaler. You're potentially re-architecting how nodes are bootstrapped, how they're patched, and how lifecycle events are handled. Karpenter uses its own bootstrapping mechanism, and while it supports custom user data, the integration surface is different enough that a migration requires careful planning and testing. A classic failure pattern here is a team that moves to Karpenter in staging. Everything looks great, and then they discover in production that their custom lifecycle hook for draining connections from their load balancer doesn't fire correctly because the node termination behavior is different from the ASG path they had before. That kind of bug can take hours to diagnose during a scale-down event. The third dimension is migration risk at scale. Moving from CA to Karpenter on a 20-node development cluster is a weekend project. Moving on, a 500-node production cluster serving real traffic is a multi-month program. You need to run both systems in parallel, which means you need to reason carefully about which node pool picks up which workloads, and make sure CA's node groups don't fight with Karpenter's provisioning decisions. You'll typically use node selectors or taints to partition workloads between the two systems during migration. That adds operational complexity and cognitive load to your on-call team. Karpenter also has its own failure modes to understand. The Karpenter controller is a deployment in your cluster. If it has a bug, or if your IAM, your identity and access management role for the controller is misconfigured, nodes stop being added. CA has the same dependency on its controller, but the CA codebase has been in production in large fleets for much longer. Karpenter is maturing quickly, but if you're at a company with a conservative change management process, the maturity argument still has some weight, though it's less strong than it was 2 years ago. Now let's talk about where Karpenter genuinely wins, because it does win in important scenarios. Scaling latency is the most concrete advantage. CA has to decide which node group to scale, then tell the ASG to add a node, then wait for EC2 to provision it. With a well-tuned setup, you're looking at roughly 3 to 4 minutes from pod pending to node ready. Karpenter bypasses the ASG and calls EC2 directly, and with consolidation and bin packing, it often gets nodes ready in 90 seconds to 2 minutes in practice. For workloads with bursty demand, that difference is meaningful. Instance-type flexibility is the second real win. If you're running a mixed workload that sometimes needs GPU instances, sometimes needs memory-optimized instances, and sometimes just needs cheap general-purpose capacity, managing that with CA requires multiple node groups, each with its own ASG, its own configuration, its own scaling logic. With Karpenter, you can express all of that in a single node pool, with a list of instance families. The operational overhead of managing 15 node groups versus 2 node pools is real. Spot interruption handling is also better in Karpenter out of the box. Karpenter integrates with EC2 Instance Connect, and the EC2 interruption notices natively. It can proactively rebalance and reprovision before a spot instance is reclaimed. CA relies on the AWS Node Termination Handler as a separate component to handle spot interruptions gracefully. More components means more things to update and monitor. So when you're in an interview, how do you frame this? Here's the structure that works. You acknowledge that Karpenter has clear technical advantages in latency, flexibility, and spot handling. Then you explain that at 500 nodes, the decision also depends on organizational factors. How mature your Karpenter operational knowledge is, how much your existing infrastructure depends on ASG-specific features, and how much migration risk the business can absorb at this point in time. Then you say that if you're greenfield, you'd start with Karpenter. If you're migrating, you'd build a phased plan, run both in parallel, and retire CA node groups one workload type at a time, starting with stateless batch jobs that are easiest to reschedule. Now let's cover the wrong answers interviewers flag. The most common wrong answer is, Karpenter is newer, so it's better. That's a red flag because it shows your reasoning from hype, not from operational evidence. Interviewers at senior levels will push back immediately. The second wrong answer is dismissing Karpenter entirely because you haven't used it. If you're interviewing for a platform engineering role at a company running Kubernetes at scale, you need to be able to reason about both tools even if your hands-on experience is primarily with one. The third wrong answer is getting lost in feature flags and ignoring the organizational and migration dimensions. Saying CA has the expander flag for node group selection priority is fine as a detail. But if you lead with that without connecting it to the broader trade-offs, it sounds like you're reciting documentation rather than reasoning like an engineer. The fourth wrong answer, and this one is subtle, is treating this as a binary choice. In practice, many large clusters run both tools during a migration period, or use Karpenter for some node classes and CA for others. Showing that you understand hybrid approaches signals real operational experience. Let's do the 30-second version of everything we covered.